Hello everyone, welcome back to the channel. Today we will finish implementing the core module of our application under the miscellaneous folder. I'm gonna add here a new file. I'm gonna call it array. Basically, if you do remember, under the Kotlin application, we have a function called distinct by. Please going to filter or to return an array by removing the duplicate values based on a key path. As a generic type, hashable, and we have to provide here the key. It is basically a callback function, if you will, to filter elements, and it has to return key. The return type of this function, it is an array of type elements. Filter, and I have to provide here the key, which is key selector as an argument element. And we have to store the visited or seen key. I'm gonna do it here before or way before the filter seen key, which is the set. We're going to check if the seen element contains this particular key. In this case, I'm going to return false. Otherwise, I'm going to insert the key to the seen set. And we have to return true. That's basically it for this thanks by. Before I forget, as a side note, under the mock URL, instead of make request, it should be make session. Now let's come back and define the other functions that we need. If you do remember again, under the util package in Kotlin, we have defined the validator. I'm gonna add here a regular expression to define the criteria for a valid password pattern. It's gonna be the default one. I have tried to respect basically the same criteria as Kotlin and the rest and the Vuetify application. Now I'm going to implement a function that's going to check whether we have a valid password or not. First of all, we're going to get the non-null value regex. Now we have to return the regular expression, first match. We have to provide here the needed string as well as the range. For the string, it is basically the password. For the options here, we don't need actually the options. And for the range, we have to calculate the range here. Basically, it is in its range. We're going to start from the password, start index, all the way to password and end index in password. The whole result should be not null. Therefore, we can say that this password is valid. The other function that we have to implement is to check if we have a valid email. If the email is empty, we're going to return false. This is basically an early return, and we have to run the regular expression by doing return. Beforehand, we have to create the email predicate. So for the self, it refers to the object being evaluated. For example, in our case, this is the email, and the keyword matches means that this particular email has to fully match the given regular expression pattern. And for the C here, it makes the comparison case insensitive. Percentage and at, it's a placeholder to be replaced by the value we have passed, some pattern, for example. And we have to provide here criteria for a valid email or the regular expression for a valid email. And at the end, we're going to do email predicate and evaluate with email, which is the input. Now I'm going to share with you guys some useful annotations or wrapped properties. I use this on a daily basis under end-to-end tests for the iOS applications that I build. It's going to be solely for testing purposes. Under util, create a new folder. Let's call it tests. It's going to be basically a structure. We're going to call it is in test environment. In Swift, we have a powerful feature, which is property wrapper. A property wrapper in Swift is a way to add reusable logic around how a property is stored and accessed. Instead of repeating the same boilerplate code in multiple properties, we're going to wrap it once in a property wrapper. And then we're going to apply it with the property wrapper. I'm going to show you just a small example to understand this properly. It's basically a normal class or a structure. This is a small example to understand it even better. Before implementing this one, let's say we want to capitalize, for example, a string. Call this structure capitalized, and we have to annotate it with property wrapper. We need to override or to define the getter and the setter. For the text that should be wrapped, which is basically a string, let's initialize it with empty string. And for the wrapper property, it is variable wrapped value we have to show how to deal with the getter and the setter. For the getter, it's going to be normally the text. And for the setter, we're going to reassign a new value of this text, calling new value, and we have to do capitalized. And this is how we defined property wrapper. And to use it, for example, in our app, I'm going to call here a structure person, for example, and we can use it like this, capitalized by doing at and capitalized and variable name and string. By doing this, it's going to automatically capitalize the provided name here without every time calling the function capitalized over and over again, which is a very powerful way, and it is readable. The main reason and the main objective of using is in test environment, it's gonna expose a boolean indicating if the application is currently running in a test environment. Let's add here property wrapper, and I'm gonna call a public static value test process argument in test environments, if you will. This is basically a constant string that represents the process argument that we will check later on. If the argument is passed when launching the application, it means that the application is in test mode. Now let's define the initializer. Basically, in the initializer, whatever we're going to put here, it's gonna runs when the wrapper is first used. And we have to assign it from using the process info. And let's add the arguments, and we have to check if the arguments contains basically this particular value in test environment. By doing contains is in test environment and test process argument, and that's all. This process info argument is basically an array of all command lines arguments the application was launched with. And basically the contains is going to check if the array includes the test process argument value, which is in test environment. Now I'm going to give you just a small overview how this particular property wrapper is going to be used in our application. And let's assume that we have a function that's going to handle the installation of dependencies dynamically in test environment, install mock dependencies. Otherwise, we're going to install production dependencies, all right? And let's say under our end-to-end test, take CUI application, launch arguments, and we have to append this is in test environments and test process arguments. As soon as the application starts, it's going to check if we have the key is this environment under the list of arguments. If it's true, we're going to install mock dependencies. Otherwise, we are not under test. We're going to install the normal dependencies. And in my opinion, this is a very good and readable and dynamic way. So let's delete everything here. And we are done basically with the test environment property wrapper. We have one last thing to do here under the core application. It's for dependency injection. We have two tasks here to do. It's to define the application container and module core application data module. Let's start by implementing first of all the application container. What we have to do here is we're going to follow the shared singleton instance pattern. Basically, we're going to create a shared singleton instance of the app container class that's going to be used globally in our application. Therefore, we have to do public static let. Let's call it shared. This approach is commonly used in Swift and in Swift in general. And the constructor should be a private constructor. It ensures that the application container can only be created once inside this particular file. Make this app container conforms to the sendable protocol. Let's import swingex library, create an instance, a private instance of the container that has been defined under swingex. And again, it's going to complain about this container because it's immutable and it is not thread safe. The only thing that I have found as a solution is to add it or to mark it pre-concurrency. I'm going to create here a function, a utility function that's going to register a dependency. Types parameter service. Let's pass as an argument the service, and it has to return the service nullable. Simply, we have to do container and resolve service type and type. Create another function that's going to register dependency in the container with the given scope and factory function. By doing container and register, we have to pass here as a first argument the service type and the factory. For the factory, it's gonna be factory, and we have to access here the resolver. I prefer to do it this way to be more readable. And we have to call the factory that we have defined by passing in the arguments the resolver. Next step, we have to call the function in object scope, and we have to define the scope or to pass the scope as an argument, basically setting the lifecycle scope, whether it's gonna be singleton scope or transient scope. And that's all for the app container sendable. Now it's still complaining about stored property container of sendable conforming to class app container has non-sendable type. Basically, it's telling us that this container type does not conform to the sendable protocol. So, as I said before, this is a safety check to solve the problem of concurrency or a race condition. And again, it comes from the fact that we are using here let. So I'm gonna create it as a computed property, if you will. Now we have the app container ready to go. Let's implement the inject property wrapper. And again, it has to be a structure. Let's call it inject property wrapper. It will automatically fetches a service from the app container. Service types parameter to inject, and you have to show how to provide the getter and the setter of this property wrapper. Now let's create the initializer for this property wrapper. And because the service is a nullable value, going to store it under service. If it's not null, app container and shared resolve. I'm gonna pass here the service and self. If it's null, what you're gonna do here is basically we're going to show an error or to crash the application by doing fatal error, and we have to pass here the message. Now we have the service. What we have to do here is to assign the resolved service to the wrapped value. And that's all we have for the inject property wrapper. I'm gonna show you here a small preview. You can do this, inject and variable, and we have to use here use cases and say, for example, some use case. This is basically how to use this property wrapper. So let's delete this. Now we are ready to define basically the core application domain module. It's going to install or register the needed dependencies accordingly. I'm going to be here inspired by Health because Health is the best framework out there for dependency injection. I'm going to provide here a static function that's going to install and register needed dependencies, API service, Pocket Goods Database Manager, as well as the crypto service. And let's do the same thing that we have done basically under Kotlin in Health by defining the module, by providing or to show SwiftUI in this case how to provide this particular this instance of type API service. I'm gonna call it provide API service. It's gonna return an API service, and we're going to use the API service builder. And this is why I love builder, because it's readable and it looks professional. Let's set, for example, the timeout of the builder. Next, we have to define the session, the shared, which is default singleton session object of URL session. Let's do, for example, the base URL, constant and API base URL. And I would like to show the messages to the console for debugging purposes. And finally, we have to do build. As you can see here, it's very good. Does look good actually with a builder pattern. Now, inside the install, we're going to register this service by doing app container shared register the name of the service. I'm going to delete everything here. Let's provide the type, which is API service self, and you have to pass here as a callback function or as a closure the function provide API service. In this particular parameter, it needs a resolver of type resolver, and here we're going to do core app data module and provide API service, and we have to pass here as an argument the resolver, which is the first parameter $sign and 0. And we have forgot here to add the static keyword because it should be static, and we are good to go. Now let's define the other dependency, which is basically for the database manager. We have to assign the database name, the extension of the database. We need to erase database on schema change. It should not be in memory, it should be a physical one, folder name, and we have to specify here the migration version. And finally, we have to build. Let's provide the last instance, crypto service. It will return simply the implementation, crypto service implementation. Now we're going to register the remaining dependencies, database manager and self. Here we have to do provides PocketGuts database manager, and we have to pass as an argument the resolver. For the last one, which is crypto service, and self provide crypto service, and we have to pass the resolver as an argument. As you can see here, this is very reusable and it's maintainable and it's readable. And that's going to conclude the core app module. For the next video, we're going to do testing to make sure that the database or the database manager is working correctly fine. And we need to make sure that we have the integrity of the data. And you can consider this as an integration test. I hope you liked the video. See you in the next one, and happy coding.